Graphing polynomial functions. For this practice test question, it asks what are the coordinates of the turning point for the function f of x equals parentheses x minus 2q plus 1. So what you really need to know is the parent function. So the parent function for a line is y equals x. Okay, so that's a line that goes through the origin straight, have a slope of 1. Okay, the parent function for quadratic is y equals x squared, and it looks like this. Okay, the parent function for y equals x cubed, it actually looks like this. Okay, so those are the parent functions that you really need to just remember. Okay, so now everything else is just a modification of the parent function. So this function is a modification of the a cubic function y equals x cubed, which is, use a different color for the graph, which is this. Okay, so that's the cubic function. And let's see what happens when we subtract 2 from x. So this is the confusing part. When you subtract from the variable x, you shift it to the right. So since the origin is here in the parent function, you will shift it to the right 2 spots. So now this turning point is 2, 0. If we just shift it to the, so if we graph that, that's what it would look like. It would shift, let me use a different color. It would shift to the right like that. Okay, but we have one more thing we did. We added 1, and added 1 would shift it up 1 unit, all the entire graph. And let me use a separate color for that. And that's how it will look like. So the turning point will be 2, 1. So it's important to know what happens when you add to the function, subtract from the function, add to the variable, or subtract from the variable, right? So make sure you have that in your note. What happens when you multiply it and the whole function, and what happens when you multiply just the variable? Those are the things that you need to actually have in your notes. Another thing I want to talk about in this recording is the end behavior. So same idea, right? So you have to know the parent function. So this is x cubed function. We know it's going to be like this, right? So one side is on the right side is going to go up to infinity, and on the left side it's going to go down. So down on the left and up on the right. So that's how those functions behave. Even if I change it, and let me just show you, I graphed it for you, right? So notice, so that is the function x cubed minus 2x squared plus 4x plus 5. So no, plus 2x. Let me change to plus 2x. And okay, so that's how it's going to look like. So notice the behavior is the same for all of those functions. I could change it. Watch what happens if I do x cubed minus 20x squared, right? It seems like, right, if you zoom in, if you don't zoom out, it seems like, oh, look, it's going down on the left and down on the right, but it doesn't. So if you zoom out far enough, you'll see actually it's like the cubic, except it goes down and then goes back up. Okay, so notice that it goes down and then it goes back up. So the end behavior is still the same. Okay, so that's really important to note that you can modify it, but the end behavior will be like the parent function. So this is an important idea for future math, and that's why I want to point that out. So when graphing, it's okay to check with a graphing software. That's what professionals do. They all have graphing softwares, and a picture is worth 1,000 words, so it's quite useful. I hope this helps you with answering your questions.